Next up is derivative combinations. When we do derivative combinations, what we have is a combination of two of our shortcuts in one problem. Like say, for instance, in this first problem, I have a function or a polynomial raised to the second power, which would require the use of the chain rule involved in a quotient. So I'm going to have to go through the quotient rule, and in the process I take the derivative of the top, where I'm going to have to apply the chain rule. Again, don't simplify. You don't need to simplify when you're doing these because it's much easier at this point for me to correct them when you don't, for me to see any issues if there are any. So just kind of go through the process, and I always talk myself through it. So this is y dy dx is the derivative, and the quotient rule says I do the low, oops, almost wrote that wrong, times the derivative of the high. I'm going to leave a little space for that. I'm going to come back. Minus the high times the derivative of the low over the low. So the denominator squared. So denominator times the derivative of the numerator, didn't do that yet, I'll get back to that, minus the numerator times the derivative of the denominator. Okay, so now let's go into this. The numerator requires a chain rule. The chain rule says I multiply the 2 in front, and then I leave the inner function as is, but lower the power 1, and then I multiply that times the derivative of the inner. So this whole big thing is the derivative of the top. And then I'm done. So this problem is complete. If you look at problem number 2, I have a similar situation where one was a quotient rule with a chain rule embedded. Now I have a chain rule with a quotient embedded. So I'm going to have to do the chain rule, but in the process of doing that chain rule, I'm going to end up doing the quotient rule as well. So similar to the first, but a little bit different, and it just has to do with what's the inner function, what's the outer function, numerator, denominator, all of that stuff. So for number 2, I have dy dx is, chain rule says, multiply the power down, leave the inner as is, lower the power 1, times the derivative of the inside. This is where the big part comes into play. Now I'm going to have to do the quotient rule for the derivative of the inside. The derivative of the inside is this big, long thing that ends up with low on the bottom. Okay, so it's denominator times derivative of the numerator minus the numerator times the derivative of the denominator over the denominator squared. Again, the chain rule with the quotient rule. So this is the derivative of the outer function, inner as is, times the derivative of the inner. And again, at that point, I am done with that problem. Next up, I have a product with a chain involved. Product of 2 polynomials, but one of the polynomials is raised to the 5th power, so that will require the chain rule. So dy dx, I go through that process, and you're going to have to know these shortcuts, so study them. It is first times the derivative of the second plus the second times the derivative of the first. So the first as is times the derivative of the second, that's the one that's going to involve the chain rule, plus the second as is, oops, I don't know why I wrote 5 there, but 2x squared, times the derivative of the first. And I'm just doing the power rule on those. Okay, so now I'm going to come back to that hard part. It's the first as is, derivative of the second. So here's the second. I'm going to do the 5 times the inner as is, lower the power 1, times the derivative of the inside. And again, I am done with that problem. We're just going to do a couple more. Here's another quotient with a chain. dy dx. Quotient is low d high minus high d low, and that's the big one, I'm going to come back to that, over low low and so now the denominator part that I have to take the derivative of, that applies the chain rule. I'm going to go back and do that. So it's the power in front, inner as is, lower the power 1, derivative of the inside. And again, I'm done. If you wanted to, you could write this as x plus 2 raised to the 6th power, but at this point, like I said, you don't need to simplify. Ooh, okay, so here's another one that is a little bit tricky, because what do I have going on here? Looks like a chain rule inside of another chain rule. So just sort of talk your way through it. The tricky part we have to think about. So the first one is this outer part, I5, inner as is, so everything stays in there as is. Lower the power 1. Now I have to do the derivative of the inside. So the derivative of the inside, the derivative of this piece. So the derivative of that piece is 4 times 5x to the 4th plus 3 raised to the 3rd power. So I brought the power down, left the inside as is. Now I do the derivative of the inside. So that's 20x cubed. And then minus the derivative of 1 is 0. Do I have to write the 0? Of course not. But that's the derivative of one part. So it's the derivative of the first piece minus the derivative of the second piece. The derivative of the first piece required a chain rule. The outside required a chain rule. So these look a little complicated, but just kind of talk yourself through it. Take your time and think about what you're writing. Same one, our last one is that same way. dy dx is the outer times the inner as is lower the power 1. Don't have to write that 1, but don't forget to put the power there. It's not always 1, it just is on this one. Times the derivative of the inside, and that's where, again, things get a little hairy, so I've got to do the derivative of the inside. That's 5 times 2x to the 5th plus 3 raised to the 4th power times the derivative of the inside of that, which would be 10x to the 4th, and then plus derivative of 4 is 0. Again, I don't have to write that thing on the end. So this is kind of a short lesson today, just practicing these combination rules. And so on top of homework 10, 6, evens or odds, I suggest that you also start working on your review. The review, or your test for B-Day people, your test is Monday. For A-Day people, your test is Tuesday. So today would be a really good job, or a really good time to go back and start working on the review. As always, if you have any questions or concerns, please just let me know. And good luck, and we'll talk soon.